So, in my last class, we actually started with a topic called features of C#.NET. In that, we already studied about three features, right? One was about platform independent, right? Second was language independent, and third was language interoperability. Platform independent, language independent, language interoperability, right? These three features. And I even very clearly have mentioned that platform independent is making CIL code, which is generated by compiler, to execute on multiple operating systems, right? And connecting with language independent, I said that you can develop a .NET application logic, where into any .NET framework compatible language. That is what I said, another point. And going forward, one more important thing that what we have studied was something related with language interoperability. That is about executing C#.NET code from VB.NET and VB.NET code from C#.NET. That was about language interoperability. And that is possible with the support of CTS. That is called Common Type System Asset. Okay, now today we are continuing and will complete the other features, because the other features which I'm going to write now, we cannot understand them. We cannot understand them at this stage, and you cannot understand, because that requires total, detailed concept, to understand that we need to start the topic, then step by step, all the things you can understand. What is that? That is something called supports all OOPS concepts. Supports what? All OOPS concepts. So obviously, when I start object-oriented programming, at that time I'll discuss what it supports, how it supports, what features it supports, all those things. Detailed study will have. Okay. Second, one more important thing we have is supports to work with what? Database programming. That is called ADO.NET. C#.NET supports to work with what? Database programming. And what do you call that as? ADO.NET. From here, or in this particular topic, you call as two-tier or two-layered architecture. Two-tier or two-layered architecture. Yeah. Why two-tier, two-layered? Why is this called? Because you're going to work with select softwares. See, one is .NET, C#.NET is there, and you start even communicating with database. Two systems, two-tier. And at that time, your C#.NET becomes front end. Your database to which you communicate, that becomes back end. And one more interesting thing that I would like to highlight here also. What is it? In this ADO.NET, we are going to cover three modules. One they call ADO.NET connected model, that you call managed provider in C#. Second, ADO.NET disconnected model. One more we have. And third, we have ADO.NET entity framework, that you even refer as EDM, that you call entity data model. EDM. So theoretical. Now at this stage, I can't show you how database programming works. I can't show you how database works. These all things when I start the topic at that time we'll discuss. Theoretical, that's it. Okay. And another feature we have, what that is called something as supports to develop what different types of applications. What different types of applications? We already know console-based applications, one category we have. Window-based applications, one more category we have, right? Console-based, window-based, different types. Now we have one more added, ADO.NET, database application, I mean, console-based application, window-based application, database application. Okay, so different types of what? Applications. And another feature we have, what is it? We are going to learn something called what supports to develop background services. Background services. How? With the help of Windows services. Yes. This is also important point. Very much required in real time. Maximum projects will have its usage. So we are going to study this with different scenarios and examples in my coming classes when I start that topic. And we have another support. What is it? Something called supports to develop three-tier architecture. What is it? Three-tier architecture. How would you develop three-tier architecture? We have a concept called with the help of distributed programming. With the help of what? Distributed programming. And what are those three? Now, that I'm going to show you. What is it called? One is called presentation layer. Second is called right? Logic, that will be for logical layer. And third one, data access layer. Types are there, types. So obviously, when you start the topic of distributed programming, we are going to study them, like what are those layers, how those layers will help you, and what is the advantage. Actually, I'm not saying like C#.NET goes exactly with only three-tier architecture. No, C#.NET even supports to develop entire architecture also. Entire architecture also. Three-tier architecture support we have. Entire architecture support also we have. Okay, and one more important point that you have is supports to work with WPF, you call Windows Presentation Foundation, which will be little extension of Windows programming. GUI programming is one we are going to study. Extension to that will be what? WPF. Supports to work with what? WPF, Windows Presentation Foundation. And this WPF, we are going to study with respect to some overview content, because WPF is one separate course. It is. So that would take at least 1 month to study in depth of WPF. You understand? So for that reason, what is important, how WPF works and all that, in whatever introduction things are there, how coding will be done in it. We have been introduced one special language by name called XAML. XAML language is introduced. So how that XAML language is used, only those things I'll highlight. Okay. These are the features that are available in C#.NET. Okay. Now, next we are going to learn something important is about CLR, Common Language Runtime. Yesterday already I said you what is CLR and all. But because I said now you got multiple CLRs, Windows CLR, mono CLR, compact CLR. For different operating systems, different CLRs are given to us. Okay. And what CLR will do? CLR always manages, right? Just manages what? CIL code. Okay. So now I'll just give you some idea what actually CLR and how it is going to work for our programming part. Open paintbrush. Okay, CLR. Microsoft has come up with one part I call languages. Okay. CLR part we are trying to come up with this. Okay. Okay. And in that languages, two things I'll highlight. One, two. Okay. One I call C#.NET. And second is called VB. Okay. In C#.NET, you write one program. In VB.NET also, you write one program. Okay. Let me write here. One program in both the languages. Here and here. Then what? Hand over this program to compiler. Same thing to compiler. Obviously, two different languages. They got their respective compilers. C# compiler. Here VB compiler. Okay. Instead of C# VB, better you would have said language compiler. Means the same. VB compiler. And what compiler will do, you already know. Compiler generates. Both compilers generates respective what? Assembly. That is exe file or .dll. Both of them, they got their own assemblies. C# assembly, VB.NET assembly. Okay. That is what? .exe, .exe or .dll. Okay. This is assembly. This is also assembly. Okay. Now, till here, okay. Individually we work. But when it comes to execution, remember this assembly and this assembly goes with execution with one common software, that is your CLR, Common Language Runtime. Till compilation, they were individual. Once compiled successfully, then execution comes with a special component that is CLR, and CLR is Common Language Runtime. How many compilers we have? Two compilers. C# compiler separate, VB compiler separate. But how do you run the code? We don't have, because we have one CLR only. Please understand that. One CLR. Because both are C#.NET, VB.NET. Both are a part of what? Both are part of what? Microsoft products. They both are categorized in what? Languages. They both belongs to .NET. So for that reason, to execute them, one CLR is enough. Common, that is. Compilers separate. CLR common. For what? To run the code. That is what I mean to say. Are you all clear with this, what I said here? Everyone in the batch. CLR related. Are you all clear with what I said? Could you figure out of what we studied in this? CLR. Okay, Jyoti. Akanksha, what about you? Prabha, what about you?
Clear, sir.
Okay, fine. Right. Okay. Now, going further, one more important part that we study now. CLR internal have approximate, I'm saying, not exact, internal. We have around 11 to 12 components inside CLR. In that, one is JIT compiler. One compiler. Second, we have CTS, yesterday's topic, Common Type System. Third is called AMM, Automatic Memory Management. Fourth is called GC, Garbage Collector. And fifth is called SM, Security Manager. And sixth is called EM, Exception Management. And seventh, we have called CL as class loader. Like this, we have 11 to 12 components inside CLR. Now, we are aware of two components from that. Which two components? JIT compiler, I have explained yesterday. CTS also I have explained yesterday. Today, we are going to learn about the first, the third and fourth now. AMM and what is called GC, garbage collector. So, before I explain you what is AMM and garbage collector, remember one thing. As the term says here, automatic memory management. Okay? Term says automatic memory management. It means before to C#, like we used to have C++ as one language. We used to have C as one language. So in these languages, we used to have in C and C++ both memory handling or memory allocation or memory deallocation. Both I'm saying memory handling, memory allocation and memory deallocation. It was completely in the hands of programmer. C++. Memory allocation process was in the hands of programmer. In order to deallocate memory also, that was in the hands of programmer. I'm talking about C++, please. If you are aware of C++, then just try to correlate. If you are not aware of C++, at least remember what I'm saying. That is enough. You don't need to have knowledge of C++. Just I'm saying that in C++ programming, whenever as a programmer we require to have memory, whenever we want to deallocate the memory once the task is completed, in C++, memory allocation and deallocation process was manual approach. Memory allocation and deallocation was manual approach. Now, when we were involved in that, there used to be a lot of problem. In allocation also we used to face problem. In deallocation also we used to face problem. And because that it was in our control, we used to specially face three major issues in C++ towards memory allocation, deallocation. Three major issues. What are they? They are actually called like this. One is called leakage of memory. One is called wastage of memory. Another one is called dangling pointers. This was the problem that we used to face in C++. So after seeing all those things, all advanced programming languages that allocation and deallocation of memory, all programming languages, they removed, say that programmer should not involve. C#.NET, you're not involved here now. You want to allocate memory, your involvement is not needed. You want to deallocate memory, your involvement is not needed. Java, Java also says, you want to allocate memory, your involvement not needed. You want to deallocate? No. As a programmer, your involvement is not needed. Python, you want to allocate memory? No. Programmer, you are not involved. Python software will take care of. Deallocation of memory, Python software will take care of. You don't need to worry about it. C#.NET same, VB.NET same, Java same, Python same, all advanced programming language. They are going with automatic process. You only say this. You only say this as a programmer. What? I want this much of memory of this type. Bus over. You leave it. Who will do the job now? Who will do the job? Software will do the job. I'll better mention here AMM and GC. And then I'm talking about in C++, memory management towards allocation and deallocation was what? Manual approach. Software was not involved here. Everything programmer used to do. Programmer's task. Because of that, what problems we faced? We faced all these issues, major issues because of this manual approach. One, I said, leakage of memory. Second, I said, wastage of memory. Then I said, dangling pointers. These were the issues we used to face in C++. Then from then, what advanced programming languages they are saying? Now what they are saying? In C#.NET, in VB.NET, in Python language, C#.NET language, in VB.NET language, they are saying now, you want memory allocation, you want to have memory management in all, memory management. Everywhere. All three, I'm saying, all three. Copy paste this. Yes, in all the cases. Memory management. You want to have allocation, deallocation? Yes. This software, advanced programming languages are saying, programmer, your involvement not needed. All are automatic. Allocation and deallocation, both. Memory allocation plus memory deallocation, both. What is it? Automatic. Then what you have to say then? If everything is automatic, what is your role? Your role is this one. You should only say to C# that I want this much of memory. And that memory should be of this type. Bas. So example I'm saying, as a programmer, as a .NET programmer, you ask for what? How much memory you want? How much memory you want? And you specify, and what type? Bas, only two things. How much memory you want? You say you want 10 bytes memory. 10 locations memory. Which type memory? Of type integer. But you just mentioned this. .NET software will do for you. What it will do? It will take care of that complete memory because it is going to deal. .NET is going to deal three types of memory concepts. Three types of memory concepts. What are they called? Three types. Let me write here. Memory types. Memory types. Which .NET deals. Stack memory. Heap memory. Stack memory. Heap memory. Then third is global memory. That is called static pool. Three. stack memory, heap memory, static pool. That is called what? Global memory. Who will communicate with all these three memories? .NET. .NET will do. You don't need to say anything. No. And memory. This is about memory type. Acha, deallocation. This is about allocation part. And memory deallocation. Deallocation. Here, who will do? .NET will do. How? Garbage collector. Yes. Allocation is automatic, deallocation is automatic. C++ में completely it was in a programmer's hand. Because of the lot of issues we used to have initially. Then in all advanced programming languages, all companies have identified how a programmer is struggling for allocation and deallocation of memory, where he is lacking in not managing memory properly. Because that he could not manage memory properly, these issues are being arised. Leakage, wastage, and then they say, no, programmer task will remove. Complete control on memory allocation and deallocation is in software today. Yes. This is one more part about the components I was discussing. In that components, this is the topic we have about what? AMM and GC, automatic memory management and garbage collector, both. Overview only. I mean, at this stage, I can't explain, what is the role of stack memory, how, when it will allocate memory for that, when it will allocate memory for it. When we start practical, probably I hope next class, we are into practicals. I'll come up with introduction to our tool, Visual Studio. That would be our first practical session that I'm going to come up with. Yes. Some components we discussed. Last class, we studied about JIT compiler. We studied about, Acha, you remember this, no? JIT compiler types were there, types. One, normal JIT compiler, one type. Second, I said pre-JIT compiler. Second. Third, econo JIT compiler. But I explained you only one in that. Normal JIT. I gave overview about all of them. Normal JIT compiler. I'll just write overview. What it will do? Required code in execution translates to native code and native code is buffered. But it is stored. Buffer mein it will store. It is buffered. Native code. Acha, pre-JIT compiler. What it will do? Translates complete what? CIL code. Complete CIL code. Translation. Complete, I'll say. Here, required CIL code. Only CIL, only code. Required CIL. Here, complete CIL code. What it will do? Translates to native code. Bas, only. It will not be buffered. Here, required CIL code in execution translates to native code, and native code is not buffered. Native code is not buffered. Native code is not stored. That makes a difference of these three compilers. We know only one. During detailed explanation on this introduction to this concept, I have come up only about this, normal JIT compiler, how it works. Could you recollect those points? Let me show you the picture once so that you can recollect what I explained you about this, what do you call, about this JIT compiler. architecture of compilation and execution. Last class, this part I covered. So .NET code, language compiler, assembly manifest, CIL code, metadata, resources. Then this assembly is given to CLR. CLR will give the code to JIT compiler. JIT compiler translates the required code. It will store in that this native code. That native code is buffered. Yesterday, theoretically, I have written all that in Notepad to come up with this picture. Compilation and execution. Okay, and one last theoretical topic is there, last one, that is called BCL and FCL. What do you call this as? BCL is base class libraries. FCL is called framework class libraries. Base class libraries, framework class libraries. What is base class libraries? Fundamentals. I mean to say like basic. Mostly used libraries in programming. Like what library? Regular, frequent, every day, every activity needs this. What? String handling, date time handling, regularly used. And FCL, advanced rules. Advanced. And where do we use? Everywhere. Where? C#.NET. Next, VB.NET. Next, ASP.NET. Next, ADO.NET. Everywhere you can use framework class libraries. FCL. Obviously, when I'm using the word libraries, you can understand. Libraries, I'm talking about some built-in things. Built-in things. This is .NET, so I'm using these terms. BCL and FCL. Achha, if it is C language, in C language, you don't have anything called, BCL, FCL. No. C language is not OOPS. C language is not OOPS language. Here it is C# is OOPS. So base class library. Framework class, like class comes OOPS. Somewhere OOPS is involved. C language is not. Then what do you have in C language? If not libraries are there, also you have library. But what library? You call in C language. We got library functions we have. Classes we don't have. Library functions we have. Built-in functions. Library functions are built-in functions. What are they? This makes a list. Printf, scanf, getch, CLR, SCR, CLR, EOL, fopen, fclose, fclose all, remove, rename, rewind, fputc, fgetc, putchar, putch, sprintf, vprintf, cprintf. All these what? Library function, built-in function. Same way, C#.NET provides ready-made things. What classes and interfaces? Base class libraries. Regular, frequently used are BCL. Advanced rules are that are applied in all languages. Framework class libraries. How do you connect this? Okay, I'll come up with one architecture on this so that you can understand the role of FCL. Role of FCL. Okay, I'll just give you a small idea so that you can compare how this FCL is going to, impact in our programming part. Okay, fine. Let's do this now. First, I'll say here C#.NET. On the other end, VB.NET. Even on the other end, ASP.NET. Okay. Now I'll club like this. These two will do common type of application. ASP.NET does some other type of application. It has got its own way of developing application, right? Two. Fine. What are they? Let me say C#.NET and VB.NET. Here, ASP.NET. Okay. Now here I mention C# VB mein I'll mention what? Windows Forms application. And one more, console based applications. Means C# VB both will support you to develop these two. I'll delete this. I'll keep them and draw the box. Transparent selection. Yeah, both. That would be best. What about ASP.NET application? What application you do? Yes, we call web forms. One more we have web services. Two types. ASP.NET. It means they got their own way of development of application. Okay, though they are developing different types of application, but they both are utilizing same software. Their environments are different. The way you write coding is different. The way you approach them is different. But in background, they both are using BCL, FCL only. Software related they are. Base class and framework class library. But the ready-made things, whichever Microsoft has provided through BCL, FCL, they both are utilizing same thing. Though their application development is different, but they both are utilizing same library. And this BCL, FCL is connected to, because of this BCL, FCL, they both are connected with common execution. But the C# needs the same, VB needs the same, ASP.NET needs the same. What do you call that? Common language runtime. CLR. Common language runtime. And then finally, yeah, who is going to, where this CLR is going to run a code, where it will run? Obviously, it is an OS. Introduction part. CLR runs the code on what? I'll write Windows 7, 8, 10, 11. What are all these? Operating systems. Yes. C#.NET way of writing code, VB.NET way of writing code is different. Right? ASP.NET way of writing code, different. Write in different, doesn't matter. But how will you write them? Common then. BCL, FCL, common. This is like sections, like if you just compare them, if you just recollect us, in school days, we used to have like, say, this is A section in the school. This is B section in the school. So obviously, slight difference may be there. A section people are little faster in understanding than B section. something, a type of categorization, right? Okay. But though it is A section, though it is B section, teacher is same only. Teacher is same. Same teacher teaches to A section, same teacher teaches to B section. And who gave this teacher? Who gave teacher? Who gave teacher? School. School gave teacher. In our example, BCL, HCL. Who gave? Microsoft gave. Company gave BCL, HCL. Common things in both areas. This is one simple representation available or to make you understand what is BCL, FCL. That is what I say. One simple conclusion I'll have. A simple conclusion so that you could figure out this in an easy way. What? To learn any programming language, not C sharp, please. Any C, C++, Java, C sharp, Python, any programming language. Compulsory as a programmer, you require to focus on two things. One, knowledge on rules of that language as a programmer. First, plus what? Plus what do you need? API required to develop applications. Two things. Knowledge on rules. Obviously, language to language rules will differ. C language rules are different. C++ rules are different. C sharp.NET rules are different. Java rules are different. As a programmer, first point that you should be focused is about to have knowledge on rules of that language. That means when you before writing a program, you should know what rules you have to follow in so and so language. And second thing, what is that your focus is? API required. Application program interface. API means ready-made things. What are the ready-made things that language provides? How to use them. How to use them to develop your application. Okay. Simple. This is one basic point to highlight how you learn any programming language. That's it. That's it. We are done with all the theoretical concepts. So Monday.